Hello, this is Yanning. Today's my progress updates for my master research detecting the cyber attack using anomaly detection methods. Today's presentation is a review. Is go with a review slides based on the January 2020's work. So, what have been updated since last presentation? So, as we can see, we have the problem statement and the introduction to the data sets, and then we have the literature review for the what is time series, what is outliers, and what is anomaly detections. Then about we compare the individual anomaly methods. So we will jump into here as the updates for the progress. So based on the label, the using of the label, we categorize our anomaly detection into 3 categories. One is supervised anomaly detection, one is semi-supervised anomaly detection, the other is the unsupervised anomaly detections. So in general, it's easy to get the label, to get the normal operations label data set, because it's happen if the normal operation is happen frequently, but we already have the like events like attacks being catched up and being labeled properly. So in the supervised anomaly detection, the algorithm is using both labeled normal operations data set and even the attack data set for this case. And in the unsupervised anomaly detection, it's not using any labeled data set. In the semi-supervised anomaly detections, is using the labeled normal operations, then to as training data set, then to predict the event attack in the testing data set. So based on the based on the besides these 3 categories of anomaly detections, we also can divide the anomaly detection algorithm to 5 categories, 5 types. One is statistic-based methods, like we can have the Gaussian distributions, and we can have the regression model. Then nearest the neighbor-based methods, which is the k-nearest neighbors, and also the matrix profile. And the clustering is k-means or PCA. And the classification-based methods is is one class SVM or boosting algorithms. Then the deep learning-based methods, we can see the autoencoder. And we color the each methods with their categories. So to compare each algorithms, each type of algorithms for the statistic-based, right? So the advantages is like it's easy to interpolate, right? And then we can but the difficulties is like it require large data. If the data set is large, right, then we need to fine tune the hyperparameters. And then for the nearest neighbors, it's also easy to calculate, but the accuracy is more rely on the quality of the data. And for the clustering based, is like no, they are not required labor data set, and also easy to faster to calculate, easy to interpolate, but the accuracy, right, also highly depend on the quality of the data. And then the feature-based measures, it not require labor data set, but it is lost informations when we are retrieve the features. Then the classification-based measures, you store it's use efficient to deliver the results as its pre-training model, and you can use it. You can do the classification if semi-supervised classification when you only have the normal operations. The deep learning methods is like you don't need feature extractions, and also it's easy to uncover the unstructured relation among unstructured data. But the disadvantages is like it's a black box, right? In how neural network arrives at a particular solution, and no standard architectures. Also, we need to fine tune the parameters to solve the overfitting. The one we are choosing for this research is we are using the nearest neighbor methods, which is matrix profile. And here is the pros and cons for matrix profile, which convince us to use it. And also we are choosing the classification methods, which is boosting, and 3 boosting methods is finally selected. Also, we are using autoencoders to achieve the detections through a semi-supervised way. Yeah, this is our proposed methods. And we evaluate the results from the accuracy, precision, recall, F1 score, and the compute the AUC. So for the matrix profile, is compute the is using this is using a slide window. It's like you define a length of the window, and a slide is we compare this window with the other using a slide window, compare the current window with the other time series. Then we can get a distance between current window with the window in the full length of time series. Then we take the minimum values, we got the distance for current window. We present this in our last 2 presentations. So, and by this matrix profile, we can get the we can find the motifs, which is normal operations, and discord, which is the abnormal behaviors. So we apply to our own to our data set selected in the research. From this diagram, you can see, right? First graph is a scaled is the scale time series data. Second graph is the matrix profile computed, and the third graph is the raw data with the motif being highlighted. we can see is that this when motif happens, the distance, we hit the minimum distance in the matrix profile. And these two in red color are the motifs we found for these data sets with a length select of 24 hours. And here we come, we apply the Discord discovery to the to our research data sets, and then we can find at this point we found the maximum the distance profile, and we are converted back to the raw data. This is the Discord we found, and it has a value which much higher than the normal days. And when looking at the raw data, we may not able to find the feature clearly, so we decompose the signals. So, like for example, for this case, this impulse signal P underscore J 300 is one of the time series in the database we selected, and after we decompose it for a total of 10, we can see the components for the signals, and the last one is a train, is the train left. And I plot this labeled attack as well. You can see from the first graph, we may not able to observing things clearly, but if we are looking at the graph here, we can see this may be this fluctuation is a bit different from the normal operations. Then this is possible the event happens. So with this matrix profile motif discovery and the Discord discovery, we build a model as shown here. So we have the firstly, we are using a training data set which has no attack. Use it for motif discoveries. We are retrieve motifs, and also we get this, like when only normal operation happens, what will be the profile what will be the distance, right, maximum distance we're going to get from the normal operations. And then this two trained by training this data set, we can get the normal operations pattern as well as a distance threshold map. Then when coming to the testing data set, we're firstly looking at all these potential Discord. And then we'll filter this Discord based on the distance threshold we are getting from normal operations. And after the Discord with the with a very shorter distance is being filtered out, we pass the rest of this potential Discord to the next step and compare it with the normal operations pattern and filter some of them by remove the regular patterns. Meanwhile, in case of missing the Discord, in case of missing the special Discord, for those who had the for those discord which filtered in this step, but has the max distance among all the discords distance from the same signal. We do another round of check. We will decompose the signal and apply this decomposed signal to a discord discovery again to decide if if we can find in the same time to decide if in the same time, right, if we can find the discord from the decomposed signals. If yes, then we will put as a potential, we will pass this discord as a potential even potential attacks. Then merge the discord past by removing pattern. Then we merge all the potential discord found. So if we decided it's right, if there's multiple sensors seeing the same discord, then we think they are we put more confidence to this discord. We put more confidence to this discord and mark it as anomalies. Here is the results we are getting after the data set goes through the model. And this is the statistics of the this is statistic we are getting from the model. As we can see is for this matrix profile model, it doesn't have good it's able to write all the anomalies, all the alarms raised are linked to an attack, but it's not catch up the start time of the attack properly. So we may not see a good statistic in this table, but it's not raising alarm in irrelevant timing, like here or here. And also, except this one, we are raising a false alarm, but we are not missing any actual event. So to come to the other methods we are using, which is autoencoder. So we are using the hidden layer of 3, compression factor 3. Then using the training data set without any attack as the training data set to build a model, then predict the testing data sets. So here is the results we are getting, and the statistics for each to evaluate the performance. So, and we can see here, even though this statistic is better than the matrix profile statistics, but from the graph, we can clearly see, right, reading the false alarm in many irrelevant timing. Also, it missed the actual event in many attacks. So to improve both, we trying to combine the matrix profile with autoencoder, and this is the combination we're getting. So we got a better model from the combinations, as we can see from the graph, also from the table. So for the boosting side, we tried the 3 methods: XG boosting, light GBM, and CAD boosting, and we are getting the results as here. Also, but the limitation for boosting is supervised learning. It's a supervised detections. So we are not use these data. We're not use this the training data set we used in the pre-seed model, which only have the normal operations. So for this boosting methods, we are using like 25% of the testing. We have two data sets which have both normal operations and attacks. So we are select for each data set, we're selecting 25% of the data, randomly select 25% of the data as the testing data set. The rest, the 75%, as the training data sets. Then we can get the results as here. So so in the next progress updates, we will go through the statistic here with the comparisons among them. Yeah, I think that's all for the today's updates.